Hi, this is a AP Chemistry video. We are going to be doing this problem, letter C of number 71 in the textbook. We're looking at there were some similar questions to this where we're looking at the pH at the equivalence point and the halfway point. The halfway point of this particular titration is not significant because it's not a weak acid or a base, but both are strong. So at the equivalence point, we know that our hydrogen ions exactly equal the moles of our hydroxide ion. So the major species that we're going to have are water and sodium and chloride ions. Maybe I should have did this before. The neutralization reaction is between hydrochloric acid and sodium hydroxide. So strong acid, strong base, salt plus water goes to completion. It's not a reversible reaction. So at the equivalence point, so when you're titrating, you're going to have that inflection. So somewhere in here, the pH is only being controlled by the water. And for water, we know that the hydronium ion or hydrogen ion concentration of water is 1 times 10 to the negative 7th. So the pH is going to be the negative log of that. And that means the pH is 7. So we are going to do the half equivalence point, even though it's not really significant for a strong acid and a base, but we can definitely calculate the pH really at any point along the curve. So we'll do this. So the first thing I'm going to do is figure out how many millimoles of acid or hydrogen ions that I have. So I know that I have 100 mils of 0.50 molar. And remember, if we do millimoles, this would be millimoles per milliliter. So that gives me 50 millimoles of hydrogen ions are present. So when we're titrating, we're starting with 50 millimoles of hydrogen ions. So the reaction that we have here is, sorry, I'm going to do something else right now before I do that. So if we're at the halfway point to the equivalence, then we're going to have 25 millimoles of hydroxide ions. So let's figure out then what the volume of base would have been that we would have added. So we know the molarity of the base, but we don't know how much. So we can easily calculate that by taking the fact that we know the molarity. So this is the same thing as 0.25 molar, which is how many moles are in a liter, but we're doing millimoles per milliliter. So when I do this, I'm figuring out how much volume of the base, because I will need the total volume of the acid and the base to do the final concentration of the hydrogen ion. So now we're going to look at the net ionic reaction for any strong acid and strong base. And we're going to look at what we have before anything reacts. So before anything reacts, we have those 50 millimoles of hydrogen ions. And now we know that we have half of that. So we would have 25 millimoles of hydroxide ions at the halfway to neutralization point. So 25 millimoles here. We're going to ignore water. So you can see that your limiting reactant is the hydroxide. It's going to get all consumed. So then after the reaction, you will have no hydroxide ions, but you will have 25 millimoles of the hydrogen ions left over. So we're ultimately trying to get the pH at this point. So we're going to get the molarity of the hydrogen ions, but before we do that, let's do the volume total now, which is the 100 mils of the acid that are given up here in the question, plus the 100 mils of base that we calculated up here. So our total volume then is, and I'm not really doing my significant figures, but it would be 200 milliliters. So now I'm ready to calculate the molarity of the hydrogen or hydronium ions by taking the 25 millimoles that are left over and dividing by those 200 milliliters. When I do that, I get 0.13 molar. So now it's really easy to get the pH by taking the negative log of that. So the negative log of 0.13 is 0.89. So that makes sense because you have a strong acid and you're in the titration curve. You're adding the base. And the strong acid's going to come down, start low, and it doesn't increase much until it finally gets to that inflection. So you're going to have a pretty low pH when you get halfway there.